Hi, this is John Linneball, and this is Barron's SAT Premium Study Guide, Chapter 6F, Polynomials. We're going to be going over the questions that are at the end of that subchapter in the Barron's SAT, whether the Premium Study Guide or the regular 30th edition. So, John Linneball Tutoring, 1859 Powell Street, number 109, San Francisco, California, 94133. Here's my phone number, 415-986-7355. Here is my email, john@johnlinneball.com, and johnlinneball.tutoring.com is where you can reach me. Now, on with the show. Question 1, page 514. If a squared minus b squared is equal to 21 and a squared plus b squared is equal to 29, what could be the value of ab? Well, we can add the equations a squared minus b squared equal 21, a squared plus b squared equal 29 to get 2a squared equals 50. So the easiest way to do it is just line them so they go up and down. We see a squared plus a squared equals 2a squared, negative b squared plus b squared, of course those cancel out, become 0. 21 plus 29 is 50. So obviously we just divide both sides by 2 to get a squared equals 25, so a is equal to 5 or negative 5. Since a squared minus b squared is equal to 21 and a squared plus b squared is 29, we can see that b squared has to be equal to 4, so b is 2 or negative 2. Therefore, b is either going to be 5 times 2, 5 times negative 2, negative 5 times 2, or negative 5 times negative 2. All of those products are either 10 or negative 10, so statements 1 and 3 work, but 2 doesn't, so the answer is D. So, question 2, page 514. What is the average, that is the arithmetic mean, of x squared plus 2x minus 3, 3x squared minus 2x minus 3, and 30 minus 4x squared? So you should know that arithmetic mean and average are exactly the same thing, or they mean the same thing, ha ha ha. Anyway, the reason that they will always give you the average and then in parentheses arithmetic mean in an SAT problem is they don't want people to complain that my teacher only taught me arithmetic mean, and someone else say, my teacher only taught me average. They mean the same thing. They're going to give you the terms. This is not where they are looking to fail you. Okay. Know what an average is. It's the sum of the numbers divided by the number of numbers. Here we have 3 polynomials that describe 3 different numbers. So this polynomial is one number. This one is another one. This one represents another number. So we just add them together and divide by 3. So first you want to combine like terms, all the multiples of x squared. Those add up to x squared plus 3x minus 4x, x squared plus 3x squared minus 4x squared, which just adds up to 0. So you see 1 plus 3 is 4, minus 4 is 0. All the x terms are 2x and minus 2x. Should be pretty easy to see that that adds up to 0. And the sum of the constants is negative 6 plus 30, because we have negative 3, 30, which is 24. So your sum is just 24, and we divide it by 3 to get 8, which is choice D. Classic SAT problem. You go through this whole rigmarole just to get one simple number. Okay. Question 3, page 514. If a squared plus b squared equals 4 and a minus b in parentheses squared equals 2, what's the value of ab? We should know that a minus b in parentheses squared is just going to be a minus b in parentheses times a minus b in parentheses, which when we use FOIL, first is a squared. Outer is negative ba. Inner is going to be another negative ba. And negative b times negative b is b squared. And yes, you could say, well, wait a minute, John. The outer was actually negative ab. Doesn't matter, commutative property, ab and ba are going to be the same thing. So, a squared minus 2ab plus b squared. So it's a good idea to memorize that a minus b in parentheses squared is equal to a squared minus 2ab plus b squared, and that a plus b in parentheses squared is a squared plus 2ab plus b squared, and of course a plus b times a minus b is a squared minus b squared. That last one, the a squared minus b squared, is called the difference of squares because it's 2 things that are squared and you're taking the difference or subtracting, and is used in many SAT and ACT problems that if you know this about the difference of squares, the problem's really easy to solve. Otherwise you really have to take a very circuitous route to solve it, and you'll probably make a mistake and get it wrong. So here we see the difference between a squared and b squared. Notice I left a space there. And a squared minus 2ab plus b squared. Okay, a squared plus a squared Okay, when we a squared minus a squared is 0. B squared minus b squared is also 0. So then if we subtract this, then you're going to get just, well, it should be actually 2ab rather than minus 2ab if we're subtracting this from this, but we could also do it the other way and subtract this from this and get negative 2ab. So minor mistake, but anyway, we can see that the numeric difference is 2 minus 4, which is minus 2, so negative 2ab is negative 2, and ab equals 1, which is choice A. The other way you could do it is end up with 2ab equals 2, and then ab is still 1. Alright, so here we go. Question 4, page 514. If 1 over a plus 1 over b is equal to 1 over c, and ab equals 2c, what is the average arithmetic mean of a and b? When I type in formulas, they put it in this font here, so this looks very urgent and italic. What is the average arithmetic mean of a and b? But anyway, so the first thing to do is to find a common denominator so we can add 1 over a and 1 over b. So 1 over a times b over b is, of course, b over ab, and 1 over b times a over a is a over ab. So the sum is a plus b over ab. It's a really good idea to memorize 1 over a plus 1 over b equals a plus b over ab, because you'll see it a lot in rate problems, and you'll need it a lot in rate problems involving two people or machines that work at different rates working together. Usually they'll actually give you the time it takes one person or machine to do the job and the time it takes another person or machine to do the same job, so you'll have to figure out the rate and add them together to find out the rate that they work together. But I digress. A plus b over ab is equal to a plus b over 2c, since ab is equal to 2c, and a plus b over 2c is, of course, 1 over c. We can multiply both sides by c to get a plus b over 2 is equal to 1. Since a plus b over 2 is the average of a and b by definition, then the answer is 1, which is choice C. Question 5, page 514. If x is not equal to 2 and x is not equal to negative 2, this is your first big clue. When you see this in a problem, that means x set equal to 2 or negative 2 will likely result in either dividing by 0 or taking the square root of a negative number, so they don't want to get into imaginary numbers, and they can't get into dividing by 0 because it's not defined. So which of the following is equal to x cubed plus 3x squared minus 10x over 2x squared minus 8? I couldn't get this nice neat formula, so we had to do it this way. Anyway, first thing you're going to do is factor out the x on the top, so this is the top, the numerator, to get x times x squared plus 3x minus 10, and then you want to factor out x squared plus 3x minus 10 to get x plus 5 times x minus 2. So the top is x times x plus 5 times x minus 2. The bottom is also factorable to 2 times x squared minus 4, so just factor the 2 out, and then factor the 2 out of negative 8, so you get x squared minus 4, which we know from the difference of squares, we just discussed that earlier, is going to be 2 times x squared plus x minus 2. If you see x squared minus any number, especially a perfect square, always know that that's going to factor to x plus the square root of the number, and then times x minus the square root of the number. So if you see x squared minus 9, you know it's going to be x plus 3 times x minus 3. You could have it be something that's not a perfect square, x minus 63, so then it would be x plus the square root of 63 times x minus the square root of 63. But on the SAT, especially if you see a perfect square, just know that it's probably a difference of squares problem, so you should automatically say, okay, what if I factor it to x plus whatever, x plus 3, x minus 3, or x plus 2, x minus 2. So notice the equation is now that I don't have quite as much clutter here, I can actually use PowerPoint's function that lets me write out nice neat equations like this. I have x times x plus 5 times x minus 2 times 2x minus 2 x plus 2. So the x minus 2's cancel out, so we now have x times x plus 5 times 2 times x plus 2, which is choice B. Notice that the x minus 2 x is not equal to 2 and x is not equal to negative 2 makes sense because obviously if you plug in either one of these numbers, it's going to be a problem. Well, actually just the minus 2 for this one. But if it's still in this form here, then the plus 2 would also cause a problem. Okay. Question 6, page 514. What is the value of a squared minus b squared over a minus b, where a equals 225 and b equals 275? You can use brute force if it's on the calculator section. Now, there's no guarantee it's going to be on the calculator section, and squaring 225 and 275, it's a little hard to do by hand because most of us haven't done a lot of multiplying 3, 4-digit numbers, things like that, since you're in maybe 4th, 5th grade. So it's not something you want to have to do on the SAT if you don't have to. So the difference of squares makes this easy, assuming that's on the no calculator section. Remember, a squared minus b squared is equal to a plus b times a minus b, and of course a minus b is equal to a minus b. So we can just take 225 plus 275 times 225 minus 275 over 225 minus 275, and we see that these will cancel out. The a minus b terms, that's the 225 minus 275 terms on the top and bottom, cancel out. So then all we have left is 225 plus 275, which is 500. Easy, easy, easy. Okay. Question 7, page 514. If x squared minus y squared is 28 and x minus y equals 8, what's the average, the arithmetic mean of x and y? Well, remember that's going to be x plus y over 2 is the arithmetic mean. The difference of squares tells us that x plus y is going to be equal to x squared minus y squared over x minus y, which, remember, we can factor this to x plus y times x minus y. So we have an x plus y on the top and an x minus y on the bottom. You're just going to have to imagine that in your mind. Those will cancel out. So we'll end up with 28 over 8, because that's x squared minus y squared over 8, which is x minus y, equals 7 over 2. But we have to find the average of x and y, and this is just equal to x plus y. So x plus y over 2 is going to be 7 over 2 over 2, or 7 halves times 1 half, which is 7 fourths. Grid in 7 fourths. Yes, you could grid in 1.75 if you wanted to, but why? That's just one extra step. You don't have to do it. If they gave it to you as a multiple choice question, there's a really good chance the answer choice would be 1.75, because then they're forcing you to take an extra step because they're mean and they want you to get it wrong. So just know that the difference of squares, what an average is, and just pay attention. I know it's hard under stress, but practice makes it a lot easier. The more you practice, the more likely it becomes that when you walk in on the real SAT day, you're just going to sit down and do it the same way that you've always done it in practice, and you're really not going to feel that stress. Question 8, page 515. What is the value of x times 2 times 3x minus 4 minus x plus 3 times 3x plus 1? So you're going to use FOIL, the first, outer, inner, last method, or whatever method you use. I know there's super diamond and all sorts of different ways that you're supposed to do it. I learned FOIL, so this is easy for me. Okay, so for the first binomial, the first term, x times 3x, 3x squared. Outer term, x times 4, 4x. Inner, 2 times 3x, 6x. Then 2 times 4 is 8, so you get 3x squared plus 4x plus 6x plus 8. 3x squared, is 3x squared plus 10x plus 8. Yeah, got a little catch in my throat there. All right. The second binomial, f, is equal to 3x squared. 3x squared. And then the outer is just x times 1. Inner is 3 times 3x, which is, okay, 9x there. And then L is 3 times 1, which is 3. So that adds up to 3x squared plus x plus 9x plus 3, which is 3x squared plus 10x plus 3. So now we subtract. We can multiply all the terms of the second binomial product by -1 to get -3x minus 10x minus 3, and then we just add everything together. So, okay, we can see that -3x squared plus 3x squared that just cancels to 0. 10x plus negative 10x is just 10x minus 10x, which is also 0. And then 8 minus 3 equals 5. So this all boils down to 5 after all this rigmarole. So we can see this is a contrived SAT problem that works out that way. It kind of makes you go, really? I had to do all that work just to get 5? Dope! All right. Question 9, page 515. What is the value of x squared plus 12x plus 36 when x equals 64? So, like a previous problem, if we have a calculator, we can just brute force it and literally just go 64 squared plus 12 times 64 plus 36 is whatever it is. What if we don't? What if it's on the non-calculator section? Simple, we can factor it. So we can see that x plus 6 plus x plus 6 give us x squared plus 12x plus 36. How do we know that? Well, whenever you're doing a problem like this, you want to look for a number that sums up to the middle term, that is the x term, and then that multiplies to, or that is the product is 36. So, okay, that's pretty easy. You can say, all right, 6 plus 6 is 12, 6 times 6 is 36. That works. Whereas if you had two numbers that add to 12, like 8 and 4, well, that would work here, but 8 times 4 is 32. That wouldn't work. So now we just add 6 to 64, because we have x plus 6, to get 70, and then you say, oh, 70 times 70. Oh, that's easy, because 7 times 7 is 49, and then, that's 10 times 10, because this is 7 times 10, so that just becomes 49 times 100, 4900. Hey, that's it. All right. Question 10, page 515. If b minus 1 over b in parentheses squared equals 4, what's the value of b squared plus 1 over b squared? We're going to use FOIL to multiply out b minus 1 over b in parentheses squared, which is b minus 1 over b times b minus 1 over b. So we end up with b squared for the first term. Then the outer is going to be b times minus 1 over b. That's a lot of b's, huh? Anyway, b times negative 1 over b, which just becomes negative 1. Then the inner is negative 1 over b times b, also negative 1. Then negative 1 over b times negative 1 over b is going to be 1 over b squared. So that ends up being b squared minus 2 plus 1 over b squared equals 4. So since we know b squared minus 2 plus 1 over b squared is 4, and we want b squared plus 1 over b squared, we just have to add 2 to each side to get that. So then we add 2 to 4 to get 6. So we have b squared plus 1 over b squared equals 6, and we're done. For the best results, use the Barron's SAT 30th or 29th or even the 28th edition. This video covers pages 514 through 515 in the 30th edition of Barron's SAT, either the Premium SAT Study Guide or just the normal 30th edition of Barron's SAT. The page numbers are the same in the 29th edition, and they're identical or close enough in the 28th and previous editions. You shouldn't use an edition older than Barron's new SAT from 2016 in any event. Not everything in the book is in these questions. Do read the book. Do look at the actual chapter. So if you're thinking, hey, I'm going to get everything I need just by watching this video, don't do that. Please look at the book. The older editions of this book can be had cheaply, if not for free, from used booksellers. Kids who've already taken the test in public libraries, they tend to sell old editions, or you can borrow the current edition. If you plan to use a library copy or a new edition, I suggest you start early. There's no worse feeling than needing a library book someone else has checked out, or trying to buy a review book that's sold out. And anyway, look, don't start studying 2 days before the test. You want to start far enough out that you can do a little at a time. There are biochemical reasons why your memory only takes so much, can only absorb so much, and that cram studying doesn't work. All right, did you find this video useful? Please like it and subscribe to this channel. Neither action costs you anything. You'll be alerted about my new videos. Why do I care? Well, it's simple. YouTube doesn't let me share any ad revenue unless I have 1,000 subscribers and 4,000 hours of view time in a year. While many people are watching, I don't have 4,000 hours of watch time. I don't have anywhere near 1,000 subscribers. If you have a copyright issue, you think that I've used something that you own the rights to, please contact me. I'd love to do that, to discuss it with you. And for the reasons I've discussed, that I don't have as many watch hours as I'd like, and I don't have as many subscribers as I'd like, you are not only welcome, but encouraged to share links to this video, put it in playlists, etc. I'm always happy to read and respond to constructive criticism or suggestions for new videos. I do reserve the right to delete comments from and block those who specialize in destructive criticism. Trolls, or things that are off topics, spammers and disturbed people. So if you want to contact me, you can call me on my cell phone, 415-623-4251. You can text me at that number. You can email me at john@johnlinneball.com. You can mail me at 1859 Powell Street, number 109, San Francisco, California, 94133. Thanks for watching. And if you need even more contact information, you can reach me on Facebook at www.facebook.com/Linneball Tutoring, one word. Instagram, you can find my Instagram for my business at instagram.com/john.linneball.tutoring. And phone 415-986-7355. Email john@johnlinneball.com. And website johnlinneball.com or johnlinneballtutoring.com. And I have a locals.com page at testpreparationlocals.com. Still working on getting that up. Quite a bit of things on there right now. And I will be getting some exclusive member-only content up on that. All right. Hope you're having a good day. Thanks.